Hello, am I audible?
Yes, ma'am.
Okay, I can share my screen. Okay, last class where we were talking about this material, basic properties of materials. On that, we have talked about cement. These things I told you it was in your IS code, IS 456. Suppose this you should have your IS code with you, right? So if I show you the IS code, this one is your IS 456. This is the IS 456 you should have with you, okay? IS 456 2000. So if we see here, what does our clause say? See here, in the IS code, all the specifications are already given. These are your materials. These are the specifications provided by the Indian Standard Code. That means regarding the cement, everything is mentioned here about cement. What should be the grade? What is the grade? What is fly ash? All those things are mentioned in your this because you must know thoroughly your IS code, like which part or regarding any material or anything which is mentioned in which clause. These things you must know. Like here, you will see in your IS code what is happening in your IS code. This is the clause number 5. What does your clause number 5 say? These talks about all the materials. That means regarding cement, all the things about the cement will be mentioned in your these clause. Okay, that means like about the grades also you can see here are different grades. What are the different grades? Cement shall be any of the following grades. Your cement can be of these grades: 33, 43, 53. Okay, these things are mentioned here. So let me. We were talking about this now. This was our class about cement. We had talked these things. Everything regarding the cement will be mentioned there in your that clause. Okay. We have talked about the different tests, performance characteristics of ordinary Portland cement, etc. Now next comes your aggregate 5.3. 5.2 was what? Your mineral admixtures. About the admixtures. We had, I think, um, yeah, admixtures also was there, na, the different materials. So regarding the admixtures, also mineral admixtures which are present in your, you can use in your cement while using your cement. These are what was running materials which are relevant to Indian standards, may be used with the permission of engineer in charge, provided that these things are okay. Silica, fume, fly ash. These are some of the risers, as I told you before also about this. Like these are your some of the admixtures which are used. Okay. And suppose this is if you're using also the risers ash, this will about the rice husk also it is mentioned some things like giving this your RHA will be giving you the required performance and uniformity characteristics may be used with the approval of the deciding authority. Okay, so one note is also given regarding that what your RHA is produced by burning, how it is produced, these things are also mentioned here. So now we were talking about our aggregates. The second one, I think we were talking about the material, which was your aggregate. This was the types of cement is given in clause number 5.1 IS code 456. 5.1, yeah, these are the types of cement or the grades of cement you can say. And regarding some of the points are given to you, low heat Portland cement conforming to IS. Okay, somebody's there. So low heat Portland cement conforming to IS, this much shall be used with adequate precautions and okay, high revenue, these things are given. You can go in detail and see just, but for our theory class, whatever is important, only that part we are looking. Actually, everything is important from here because when you are related to this materials, when you're using these materials, how you need to check the quality, what are the importance of these, all those things will be in your IS 456. So you should know your IS. So now if we talk, last class we have talked about aggregates also, I think that is your 5.3. In IS code 456, Indian Standard Code 456 2000, aggregates, the clause number 5.3 discusses about your aggregate. That is, your aggregate shall comply with the requirements of IS 383. As far as possible, preference shall be given to natural aggregates. Okay, but since the resources are decreasing, the availability of resources are decreasing, so what happens? Natural aggregates not possible for everybody to take the natural aggregates in some of the places, so obviously they have to purchase it. Okay, artificial ones, you have artificial means breaking the blasting and taking the aggregates from there. Okay, other types of aggregates shall such as slag, crushed, overburnt brick or tire, which may be found suitable with regard to strength. Okay, bricks also sometimes they are used, or the tiles. Slag and the crushed overburnt bricks broken, they can also be used as aggregates sometimes. Okay, not natural one, but so some of the important things are there, like size of the aggregate. For most work you can see here 20 aggregate is suitable. This is important, right? 20 aggregate is suitable. The nominal maximum size of the course aggregate, this is the size of the aggregate is important. According to your IS code, you have to know what should be the size of your aggregate when you're for a particular type of work where you need your aggregates. Okay, like here, the nominal maximum size of course aggregate should be the nominal maximum size of the course aggregate should be as large as possible within the limit specified, but in no case greater than one-fourth of the minimum thickness of the member, provided that the concrete can be placed without difficulty so as to surround all the reinforcement thoroughly and fill the corners. Okay. So the maximum size should be how much? 1 minute. Huh? Hello? 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 Yeah. So the for most work, 20 aggregate is suitable. Oh, where we went? Yeah. The nominal maximum size of the course aggregate should be how much? The maximum size which you can take is be as larger as possible within the limits. So the limits were specified by IS code, but in no case greater than one-fourth of the minimum. Okay. So as much as you can, the larger aggregates you can take. That is your maximum size. But it should not be greater than how much? One-fourth of the minimum thickness of the member. So you are taking some aggregates. You are taking some aggregates. So you are taking the aggregates. So what happens? One-fourth of the minimum thickness. So suppose minimum thickness. Suppose you are getting here the minimum thickness is your 20 mm. Suppose 20 or 19 or 18 suppose I'm telling. So what happens? You have this minimum aggregate. So the maximum will be how much? One-fourth of your the minimum thickness, whichever is your minimum thickness of the aggregate. Suppose 18 we have taken 18 mm. So this will be your maximum size of the aggregate which you can take without difficulty. Okay, so that is mentioned in your this IS code. Now the most general, which one we are using, 20 aggregates are generally used for our works aggregate where there is no restriction to flow of concrete into the section. 40 or larger size may be permitted. Okay, so there are some restrictions. Okay, in your suppose you're constructing a building, there may be some restrictions regarding that, like the weight of your building is going to increase when you use your maximum size of the aggregate. So the minimum or the general, the normal is how much? The nominal one is 20 mm aggregate is suitable, and maximum if you want it is 40 mm. Okay, or one fourth of the minimum thickness of the aggregate of the member. Sorry, okay. Minimum thickness of whichever member you are making, like if it is beam or column, okay, or slab with, okay. So in concrete elements with thin sections closely spaced reinforcement, okay. Plums above 160 mm and up to any reasonable size may be used in plain concrete work. All these things are mentioned the specifications. We have discussed this. Okay. So regarding that, now comes your clause number 5.4. Clause number 5.4 about the water. This is also one of the how many materials was there for your concrete? Cement, aggregates, water. Right? Cement, aggregate, water. And what was the aggregates? It can be either fine aggregate or coarse aggregate. Fine aggregate was sand, coarse aggregate was your stone or the aggregates sizes we have discussed in IS4. Everything is mentioned. So minimum was 20 mm, that means a normal size 20. Where you have no restrictions, you can use to be 40 mm or greater than that, like one fourth of the minimum member thickness of the member. Now comes your water. The another material which was used for your concrete was water. Clause number 5.4. This one 5.4, water. So what is that? Water used for mixing and curing shall be clean and free from injurious. These things are known to you. They should be free from your chemicals. Okay. Potable water is generally considered safety for mixing concrete. As a guide, the following concentrations to neutralize 100 ml sample of water using phenolphthalein as an indicator. It should not require more than 5 ml of 0.02 normal NaOH. The detail of tests are given in 8.1 of IS code. Okay, so to neutralize 100 ml sample, these are said to be, in case of doubt regarding the development of the strain, the suitability of the water for making concrete shall be ascertained. The sample of water taken for testing shall represent the water proposed to be used for concreting, due account being paid to seasonal variation. The sample shall be stored in a clean container, previously rinsed out with similar water. Average 20 days compressive strength of at least 3 150 mm concrete cubes prepared with water proposed to be used shall not be less than 90% of the, okay, at last 3 150 mm concrete should not be less than 90% of the average strength of the 3 similar cubes prepared with distilled water. The cube shall be prepared. This thing you know, cubes you have to prepare to find out the average compressive strength in 20 days. The square cubes you have to make the square cubes of 150 mm, 150, so these are square, okay, 150 150 150 3 cubes you have to make. So the average, yeah, that cube when it is mixed with water and that is formed, that cube it should not be less than 90% of the average strength of the three of these cubes, okay. And the water that is used is your distilled water. The initial setting time of test block made by this is 30 minutes. Okay, it should not be less than 30 minutes and shall not differ by plus minus 30 minutes from the initial setting time. Initial setting time, you know, it is 30 minutes. Previously, we had talked in the fourth semester this test of Siemens. Right, that the pH value of the water shall not be, this is important, pH value of your water which you use for making your concrete or mixing your materials together, like that of your aggregate, cement, all those things, coarse aggregate, fine aggregate, to mix together and form the concrete. The pH of water which you are using should not be less than 6. Okay, this is important, very important. Okay. Here are at IS4 gives you some permissible limits, which are the maximum limits of the your permissible limit for solids is how much. For organic, according to IS 3025, not possible to keep all the IS codes, right? But when you are doing some particularly on some topics, then you need to have the IS codes of these IS 3025, 3025, part 18, 24, and 32 for different solids. Okay, these are the permissible limits. So you obviously you can't, it is not possible sometimes to remember this thing. So that's why IS code is provided. Whenever you design something, you have to have your IS code, and whatever is mentioned according to the specifications, like this is the permissible limit, so you will check the permissible limit for organic matter or organic solid in this code IS 3025 part 18. That is how much it is mentioned there, that it is 200 milligram per liter. Okay, so next, if you have from your water, okay, water cement ratio for 20 days. These are your water cement ratios 4.4. In 28 days strength is how much? 28 days strength is this much. Okay. Here also it is mentioned. This thing was given in your IS code. I showed you just now. pH, which value, all these are in short. It is mentioned here in the table. Okay. The permissible limits are also shown. These you have to know which clause it is for the water. So now, in short, if you come to the admixtures, clause number 5.5, this one, what does IS code specifies? That admixture, if used, shall comply with IS, this one. When we use IS code, we have to use with respect to what is mentioned in your IS 9103. Previous experience with the data on such materials should be considered in relation to the likely standards of supervision and workmanship to the work being specified. Okay, admixture should not impair durability of concrete nor combine with the constituent to form harmful compounds. Your admixture should not be such that it forms any harmful compounds. Okay, the workability, compressive strength, and the slump loss of concrete with and without the use of admixture shall be established during the trial mixes before use of admixtures. Okay, so these before you use any admixtures, we have to see the workability, compressive strength, and the slump test of concrete both with and without the admixture. Okay, so that we can compare how much whether your admixture is working properly or not, whether it is giving you the required strength or not. Okay, so again another clause 5.5.5, what it says, the chloride content of admixtures shall be independently tested for each batch before acceptance. Okay, this chloride content should be tested in the admixture. That means whatever admixture you're using, whether it be your lime, whether it be your ricer's ash, or whether it be your fly ash, any kind of admixture if you use. So before that, you have to check your chloride content test. Okay, if two or more admixtures are used simultaneously in the same concrete mix, data should be obtained to assess their interaction and to assure their compatibility. These things you should have. Now, coming to the reinforcement of clause number 5.6, what does this code specifies? That mild steel and medium tensile steel bars conforming to IS 432 part 1 shall be taken. High strength deformed steel bars conforming to IS. Okay, these are regarding your reinforcements. We were talking about the water and the admixture. Done, fly ash, groundwater, ricers, metakaolin, all these are different admixtures which have some pozzolanic characteristics, okay, which help to, like the cement, they also help to uh, form a cohesive characteristics, and they form or they combine together your concrete, the coarse aggregates, fine aggregates together, okay. So, properties of your fresh water, when you see the properties of fresh water. Now, if we talk about the properties of fresh concrete, these materials are done now. That means the for concrete, you know the aggregates. Sorry, for concrete, you know what are the materials: cement, aggregate, water. Right? Cement, aggregate is fine aggregate, coarse aggregate, fine is your sand, coarse is your the aggregate of different sizes. Okay, now when you use those, and also admixture you can use sometimes when you want the strength to be more, or you want to decrease your quantity of cement and add some admixtures to that. So that is also one material which can be used with your concrete. That's why we have discussed about our admixture. Okay. Now, when we talk about your properties of fresh concrete, what you have to look, the most important one is when we talk about concrete, we have discussed that it should be the workability should be there should be your concrete should be workable. That means with the ease with which the concrete can be mixed. What is workability? Workability is the ease with which the concrete can be mixed, placed, and consolidated and finished. Right. So these is your fresh concrete properties. We are talking about the properties of now fresh concrete. What should be the property of a concrete? Good concrete, that it should be workable. The work, that's why we check the workability, right? We have done that in fourth semester also about the workability of concrete. Workability, slump by slump test you see that. Okay, so workable concrete is the one which exhibits very little so in detail if you go, what is that workability? That means the workable concrete is the one which will exhibit very little internal friction between the particle and the particle on which overcomes the frictional resistance offered by the formwork surface or reinforcement contained in the concrete. Okay, so the factors which are affecting Okay, the factors which are affecting the workability are given below. So, what are the factors that are affecting your this workability? That means how easily your concrete can be mixed, okay, or placed wherever you want in a structure member. How it can be placed easily or mixed easily, and then placed and then used together. So that depends upon what? That depends upon the water content, how much your is your water content. Because what will happen if your water content is more in a mixture, concrete mixture, if your water cement ratio, in the water cement ratio, if your water content is more, what will happen? Your cement, your concrete will be very liquidy, so it will not give you the proper strength, and it will not be placed properly. It can be in the mold, you can place it properly, but it is not going to set fast. It will take more time. Okay, so it will not give you the proper strength because of the more amount of your water. Then the mixed proportion, how much whether your mixed proportion of your cements and water is correct or not, you have to know that. So that will come later. So cement, water, and aggregate. Okay, so that you have to, the mixed proportion should be well. If your cement is more, your aggregate is less, your water is okay. So what will happen if the proportion is not good, your mixed proportion is not well, not good, what will happen? You will have less. If you have lesser aggregate but you're giving more cement, so what will happen? Cement is very much weak in tension but good in compression. You people know that. So how it is good in compression, but if you use suppose less aggregate you're using but more cement, your cement is going to crack. And since the aggregate gives you the required strength to hold that loads or to resist the loads, so what will happen? Your member, the member which you're making something, some member you're constructing, if the proportion is not good, if the proportion your aggregate is less but your cement is more, what will happen? It will your aggregate, the required strength which you should give, that member should give, it will not be achieved, right? So size of the aggregate, one another important factor is what? Your size of the aggregate. So size of the aggregate, I told you, I showed you in the previous class. Size of the aggregate shall be how much? These are your size of the aggregates. The specifications are given to you. How much should be the, see here, for heavily reinforced concrete members, as in the case of ribs of main beams. Suppose main beam you are making. This is written about the reinforcement. Okay, like when we use reinforcement RCC, for RCC, this clause is for RCC. This is for your normal concrete. This is for your RCC. How much is the aggregate size? That is, the nominal or the maximum size of the aggregate should always be restricted to 5 mm less than the minimum clear distance between the main bars. Okay. That means, suppose your minimum clear distance between the main bars, these are your Suppose main bars in your beam. So main bars in the beam, the clear uh, distance is how much? The clear distance between them is how much? That is, suppose 12 mm. So that 12 mm minus 5, because 5 mm less than the minimum clear distance between the main bars. Yes or no? So, or 5 mm less than the minimum cover of the reinforcement shall be whichever is smaller. So, whichever is smaller is your nominal maximum size. So, the maximum size, this thing is very important. This you have to know regarding your RCC. How much is the aggregate size? How much is the maximum size of the aggregate? That is smaller of these two. That means this one, the clear distance minus your 5, or the clear cover. Suppose um, your clear cover is suppose 10 mm, so 10 minus 5, whichever is smaller, that will be your maximum size of the aggregate. That means your 7, this is your 5. Now whichever is smaller, so which is smaller? This is smaller, so that means this is your maximum size of the aggregate. This is just an example, okay? Need not to take 5 only or 7 only, it will be more also, sometimes it will be less. So this was your maximum size in RCC of the aggregate. That means it's smaller of these two, that is the main bars distance minus 5, or the clear cover minus 5, whichever is smaller. Okay, so this was your factors which are affecting the workability. Okay. Now the shape of the aggregates. What should be the shape of the aggregate? Surface structure of aggregate, grading of aggregate, use of aggregates. The following tests are commonly employed to measure the workability. That is slump test. You know about the slump test, right? Last semester we have done already. So slump test, compaction factor test, flow test. You can do from these things, but we generally do the easiest and the simplest and the correct way is your slump test, which is the most favorable one. Okay, these are also some of the tests, okay, which can be done in the outside, but here we always mostly use the slump test to find out the workability. Okay, again another property of your concrete is what? The segregation. You have to see the segregation property of your concrete also. So what is that? So what is that? The segregation can be defined. Now what is a segregation? What do you mean by segregation? Segregation can be defined as the separation of the constituent materials of concrete. Okay. So a good concrete has all its, okay. Segregation can be defined as a separation of the constituent materials of concrete. Segregation means what? When the materials which are used in the concrete, like the what we say, the cement, fine aggregate, coarse aggregate, and what? Your water. So if we separate these from your concrete, that is your segregation of the concrete. Okay. Now a good concrete has all its constituents properly distributed to form a homogeneous mixture. To ensure this, a good concrete has all its constituents. Okay, a good concrete has all its constituents properly distributed to form a homogeneous mixture. You know, obviously this thing. So to ensure this, optimal grading size, shape, and surface structure of aggregates with optimum quantity of cement and water makes a mix cohesive. Such a concrete does not exhibit the tendency of segregation. Okay. Prime cause of segregation is what? Now segregation means, you know, that is the separation of your this one constituent materials of the concrete, whatever is the materials, the main materials inside the concrete, the separation of that. How does that happen? Segregation can happen. The main how a good this thing will what happen the to ensure that your segregation doesn't take place, your optimum grading, size, shape, and the surface structure of aggregate with minimum quantity of cement and water makes a mix cohesive. Such a concrete does not exhibit the tendency for segregation. Okay, so when you have your cement and your water is at a very good proportion, in the exact proportions, your segregation doesn't happen. Okay. Prime cause of segregation. Now what is the main cause of your segregation? Sometimes you may have seen segregation means what? Suppose you are looking in your house, or in some site also you can see. Suppose there is suppose a wall. Okay. Wall or a pillar or column. What happens? Sometimes what happens, you will see some part of that column or a wall comes out. That means the aggregate cement mixture, it comes out. No, it gets separated from that member. So that is called your segregation. Okay. So the why does that happen? Because the main cause of that is the difference in the specific gravity of the constituents of aggregate. So there will be the the different specific gravities of your materials that are used. So because of that, this happens sometimes. Okay. Segregation may be one of the following types: core segregate, separation out of the rest. What may bond? No, no, no. Okay, sorry. So, what I was telling, yeah, separation may be one of the following. What is a segregation? I told you that segregation can be what? Segregation can be of the either it can happen what from your material. Suppose suppose you have a material. Okay. This is your material. Suppose this is a column. Yes. So this is obviously made up of what? Reinforcement. Reinforcements are there, right? Aggregates are there, aggregates are there, cement is there, these things are there. No? So what happens? Segregation may be one of the following. That is core segregate, this core segregate, that is this part, this one suppose, this core segregate, suppose this is at the corner here suppose. So this aggregate may come out, this aggregate may come out, or this corner aggregate may come out and fall. So that is the separation. That means only the coarse aggregate is coming out sometimes when it is at the very edge. So what will happen? That means what? This is called your, this segregation is one type of segregation where your this coarse aggregate is only coming out. So separation of this coarse aggregate from the rest is your segregation, one kind of segregation. The other kind of segregation is what? Cement paste or cement fine aggregate matrix separating from out from coarse aggregate. This is the coarse aggregate. So sometimes what may happen here, with each of the coarse suppose this one, suppose this was your coarse aggregate. Here on the coarse aggregate, obviously here, since this is mixed, all this coarse aggregate is mixed with sand, cement. So what may happen here, obviously in your this coarse aggregate, it is, since it is mixed with everything together, so here sticking on the aggregate, there will be cement will be stick to that, and then sand will be stick to that. So when these together comes out, cement fine aggregate matrix separation from the coarse aggregate. This is the coarse aggregate. From here at the edge, suppose the cement portion and the sand portion is mixed here, it comes out from the aggregate is here only, stick to this column only, but from the very edge your cement sand, the which is stick to that, is coming out, okay, due to some reason. So that is called your what, the segregation when your cement or fine aggregate is matrix separation from the core segregate. That means the sand particles are coming out. Okay. My God, so many trees are there. Just give me a second. Okay. So the other one is what? Water separation out of the rest. Water may leak due to excessive water when you are mixing the concrete together. The mix proportion is not good. Your water content is more, or if due to any reason, your water may leak. You have seen in some of the structural members that there is leakage of water from that. You will see some markings of your this thing, the water kind of thing, marking means what? You will see some marks of those liquids, okay, sliding down, or you will see some patches. So that is the separation of that water from rest of the materials. Okay. Now the conditions that favor segregation or what? This is nothing but similar to your cause of segregation. Okay. So what is that? So what is that? That is how your this bad mixture, due to bad mixture, your segregation may take place due to bad mixture, due to inadequate mixing. Mixing is not good. Excessive compaction by vibration of wet mix. Large height of dropping of concrete for placements. Long distance conveyance of mix. Okay, these may be the reasons of your conditions, favorable conditions for your segregation. Okay, bad mix proportion when mixing is not good. When you're uh, suppose you have mixed something, your concrete materials you have mixed together, but for a far off distance you are taking to a very far off place. So in that case, there may be some loss of your there may be some loss of your what, some of the materials, so the mix proportion gets uh, the mix proportion, what will happen to that mix proportion, that will get what is that called, the mixture, since your mix proportion was good when you had mix, but when you went so many markers are there. Do one thing, I'll give you the attendance link now. You just go to the attendance link and give the attendance. We'll join the class after 10 minutes, 10-15 minutes we'll join again. I'll share the link. Okay. My God. Structure. I have shared the attendance link. You can go and give the attendance. Here in the chat box, I have shared. Go to the link and give the attendance. Okay, here I have shared the link for your attendance. Take the link and give the attendance for this class.